I'm Dylan. In this video, I'm going to go through binary arithmetic subtraction. So first of all, let's review some basics of subtraction. So the concept of subtraction is the process of taking a quantity away from another. So for example, I have 6 chickens. Someone takes 3 away from me, then I have 3 chickens left. And we have some names for each of the element. First of all, we have minuend. Minuend is the number that is to be subtracted from, and then the number after the minus sign is what we call subtrahend. Subtrahend is the number that is to be subtracted, and then we have the result difference. So the process of subtraction is pretty intuitive. We can write the number vertically and line them up. Then we subtract the number on each digit to obtain our difference. So when working with multi-digit subtraction, sometimes we run into a problem where the number on the first place is not enough. So we have to borrow from the next digit, which is the 10th digit. So in this case, 765 minus 39, 5 is not enough to subtract 9. So we have to borrow a digit from the next digit, which is 6. So since we're working with a 10-based system, a decimal system, we have to borrow 10. So our 5 will become a 15. Then we have to rewrite our 6 into a 5. Or you can regroup the number, change the 3 on the bottom into a 4, and then we can do our subtraction. 15 minus 9 and 5 minus 3 and obtain our final answer 726. And here's a summary of multi-digit subtraction, from the easiest one where you don't have to borrow any digit, and to the hardest one where you have to borrow the digit multiple times, since the number on the 10th digit is not enough to subtract the 6, so we have to go one step further to borrow from the hundreds. So sometimes we might run into a problem where the value of our subtrahend is bigger than the value of the minuend. So in this case, we have 3 minus 4. So one way to think of this problem is to think of it as numbers, as particular points on a number line. And when subtracting a negative number, you simply move to the left. So we start with 3, and we can move 4 steps to the left, which we have -1. So, and another way to think of this problem is to change subtraction into an addition problem. So instead of writing 3 minus 4, it can rewrite it as 3 plus -4. Either way will give you the same result, -1. We can apply the same concept to the binary system. So when working with subtraction in binary system, we simply rewrite the decimal into the equivalent binary form, and we line up the number digit by digit, and then we subtract the number on each digit. Keep in mind that since we are working with binary system, when we borrow a digit, they are base 2. So instead of 10, we're gonna borrow 2. So for example, 26 minus 12. First, we will write the number into its equivalent binary form, and then we subtract the number on each digit. So notice when we work on the third digit, 0 minus 1, we do not have enough digit, so we have to borrow from the next one. So we borrow 2. 2 minus 1 gives us 1. When we move on to the next one, that one becomes 0, so we have to borrow it again from the next digit. When we borrow 2, 2 minus 1 equals to 1. And the next digit becomes 0, and our result is 1110, which equals 14 in the decimal system. So when working with signed binary numbers, which is negative numbers, we first have to convert the binary number into a complement number by flipping each digit. Then we have to add 1. So for example, we have 17 in decimal. Then we convert into binary. Then we flip each digit and we add a 1. We can verify the result of subtraction with an FPGA board. So in this case, we have 2 two-digit input and 1 4-digit output. In this case, the value of our A is 10, and the value of our B is 10, which is 2 minus 2. and our result is 0. And we can see on the board no light is on. Our value is 0. So likewise, in this example, the value of our A is 10, which is 2, and the value of our B is 01, which is 1. And 2 minus 1 equals to 1. And let's check our board, and the answer is indeed 1. Only one light is on. What about signed numbers? So in this case, the value of our A is 10, which is 2, and the value of our B is 11, which is 3, and 2 minus 3 equals to -1. So we are expecting a result of -1. Let's check our answer. So we have 1111. It's a signed 4-digit binary number. So to verify our answer, we can convert 1 into -1. So 1 has a binary number of 0001, and it has a complement of 1110. When we add 1, we get 1111, which is -1. And -1 in this case indicates 4 lights on. And as we can see on the picture, it is indeed -1.